This is the real Tom Rose, and the reason why this question is so difficult is because you need to keep from becoming confused by the various multipliers that are involved here. So for the original square that they give you, for example, let's draw that here, has a diagonal that measures 2x, right? And then it says they have a second square that has twice the area of the first. I'll draw that over here. Doesn't even fit on the screen, right? The perimeter of the second square is what we want. Now, if so, we need to calculate the length of one of these sides of the second square. Now, if the second square is twice the area of the first square, then the value of the side lengths should be multiplied by root 2. Right? So imagine that you might be tempted to double it, to double the length of the side. But for example, say a square has a side of length 1, hypothetically. The area of that square would be 1 squared, which is 2. If you double the length of one of the sides, that becomes 2. Calculate the area of that square. 2 times 2 is 4. So by doubling the side length, you've actually quadrupled the area. So if you want to double it, you actually want to multiply by the square root of double, which is 2. So the square root of 2 is the side multiple. So instead of 2x, and that goes for any measurement, will be 2x root 2 will be the measure of the hypotenuse for that square, or the diagonal for that square. Now, this square is made up of 45, 45, 90 triangles, of course. And the ratio of sides for a 45, 45, 90 triangle is 1, 1, root 2. Right? 1, 1, root 2, like that. So if you want the length of a side, we need to take the diagonal, divide by root 2. So this is 2x root 2 divided by root 2. So that's just 2x. So if 2x is the length of the side, and we add up 4 of those, the answer will be 4 times 2x, which is 8x. If the presence of the x was messing you up this whole time, feel free to just pick a number for it. So if you want, at the beginning of the problem, go ahead and set, it's a nice little trick here, go ahead and set x equals 1. And just do the whole problem with x equals 1. So this hypotenuse would be 2. This one would be 2 root 2. The side length here would be 2. And you'd calculate, boom, 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 you'd get, instead of 8x, you'd get a length of 8. You'd also need to plug these 1s in for all the x's to evaluate this. But when you plug that in here, you'd get 8 if you plug in a 1 for x. So you'd get a match there. So if the x is messing you up, just, plug something in for it.